Hi, I'm Jae Kim with Scientific Analog. In this short video, I'd like to show you how to use XMODEL with Cadence Virtuoso. This video assumes that you have already set up XMODEL and Cadence Virtuoso properly. If you haven't done so, you can visit our support website at www.scianalog.com, where you find the downloads link in that website and find the XMODEL installation guide, which explains how to install XMODEL as well as set it up to use it with Cadence Virtuoso. To follow the steps described in this video, we need to first copy the tutorial material included in the XMODEL package into your home directory. For instance, you can execute the command copy -r $home/tutorial/xmodel_basic and dot to copy the XMODEL basic tutorial into your home directory. This directory actually contains a lot more material than we're going to describe in this video. For more detail, please check out our support website again. One of the subdirectory included in that xmodel_basic is the Cadence directory. Inside it, there are some necessary files to use Cadence Virtuoso, and there are two things you need to check before starting the Virtuoso session. First, make sure that your cds.lib file or lib.dev file includes this line, which includes the library definitions for XMODEL primitives. Second, also make sure that your .cdsinit file, which could be located in the current directory or maybe the home directory, includes these 4 lines, which loads the context file for XMODEL and initializes it. Now we can start the Cadence Virtuoso. It pops up the main window called Command Interpreter window. First, let's open up the Library Manager window to see what we have access to. This XMODEL_prims library is a library that contains XMODEL primitives. You can see a lot of them here. And to browse them using categories, you can check the Show Categories options and select each category to see what primitives you have for each of them. Each category also has online documentation. You can access them in a web browser by simply double-clicking the doc view. In this short demo, I'd like to show you how to compose a very simple model schematic in Cadence Virtuoso and run simulation with XMODEL. To do that, let's first create a new library named Sandbox, like this. So now we have a new library created. After that, let's create a new cell view, new schematic cell view, named Castle. So it's Castle in a sandbox. Now it opens up an empty Schematic Editor window. For this example, I'd like to try generating 2 sinusoidal signals with different frequency and add them up to see what we get. To do that, we have to place a few XMODEL primitive instances. To do that, go to the Create menu, select Instance Item, or you can simply press I as a shortcut. When it opens up an Add Instance window, click Browse button and select XMODEL Primitive Library, Stimuli Category, and SignGen cell. We see a list of parameters you can use for this primitive. For example, I'd like to generate a sinusoidal wave with 300 megahertz with an amplitude of 0.2. So I'll place it right here. For the second sinusoidal signal, I guess I will do a different approach by placing it first and modifying its parameter. And this time I want a bigger amplitude but a lower frequency of 28 megahertz. I like to add them up, so I need to have an adder. The primitive that XMODEL primitive that does addition is called add. And you can have an arbitrary number of inputs. So in this case, I only need 2 of them, so the default setting is okay. And I'm going to place it right here. Now I need to connect these terminals of different primitives. To do that, go to the Create menu again and select Wire, or simply press W as a shortcut. And we're going to draw wires by clicking the starting point and the ending point, like this. And then I'm going to draw another wire for the output signal. This wire goes nowhere, so I'm going to add a pin so that I can connect to a different cell. To do that, go to the Create menu again and select Pin, or press P. I'm going to name this output pin as Out, set the direction to Out, and then place it on the schematic. It also sets the name of this output signal as Out. But these signals, the 2 sinusoidal signals, don't have name yet, and they will get an arbitrary name that Cadence assigns. To set the name with the one that I want, you can go to the Create menu, select wire name, or press L as a shortcut, and then assign their names. One nice trick is that in case you need to assign multiple names, you can list those names with spaces between them. And that way you can assign different names just by clicking different wires. We're almost ready. One step left is to add a dump primitive so that you can record all the signals on this schematic to a waveform file. To do that, we're going to use a dump primitive. With default setting, just by placing this dump primitive on the same schematic, it will record all the waveforms into a file. Now you're ready to run XMODEL Simulation. Before you run any simulation, please make sure that your schematic is checked and saved by pressing this button. Then go to the XMODEL menu, and let's see what kind of netlist will be generated from this schematic by pressing this Generate XMODEL Netlist button. When you execute this, your command interpreter window shows that Glister has run and the model netlists are successfully written. To view it, select Display XMODEL Netlist menu, which will pop up a text editor that shows the XMODEL netlist. You can see that there are a list of 3 XMODEL primitives, 2 sign gen, and 1 add. You can also see these statements that direct XMODEL to dump waveforms into the file. Now, let's run some simulation. You can select Run XMODEL Simulation menu item, which will open up this XMODEL Test Bench editor. In this case, we are running simulation directly from this schematic without additional test bench, so all we need to do is to set the simulation time and the timescale. You can set the simulator of your choice by selecting any items here, or leave it blank to use the default setting. Now, next step is to just press this button to run the simulation. Let's do it. See that the simulation is launched and finished. To view the resulting waveform, press this waveform button that says Plot Waveforms. It opens up our X-Wave waveform viewer. If you go to a schematic editor, you can notice that your cursor now has dot signs on it. It's in a probing mode. So by clicking the wires that you want to see waveforms of, you can notice that the X-wave will display the waveform that you just selected. So we have two signals, A and B, one with a small amplitude but high frequency, the other with a low frequency but high amplitude, and we can see the resulting waveform that adds these two. This X-wave waveform viewer supports many features that you can typically find in other waveform viewers, such as zooming, panning, as well as using cursors. For more details on how to use X-wave waveform viewer, you can refer to the manuals. This short demo showed how to compose model schematics in Cadence Virtuoso, run XMODEL simulations within it, and even browse waveforms after the simulation. Hope you find this as a good starting point to compose something more complicated and meaningful. Thank you.